Okay, so in my experiment, I have 3 boxes of crickets, all with the same number of them. So this is box 1, this is box 2, that's box 3. So box 1 gets 5 milliliters of water. Box 2 gets 10. These 2 are the test subjects because box 3 gets 15 milliliters, and that's approximate to the natural amount of rainfall that would fall into a farm, like a peach farm, right through the year. That's necessary for the plants to survive. So this is the control group because of that, to see how the crickets in that environment would actually react. And then here, this is a little bit lower, about 5 milliliters lower, so we've taken it down a third. And then this one, we've taken it down 2/3. This one, the plants would have, probably not survive very well because they would be dehydrated along with the crickets, but at the same time, it would push the crickets out of the environment because it's probably not enough to sustain them. For this one, it's more likely for the plants to survive, but it's also more water, so it's a little less likely that the crickets might leave. But at the same time, it's also not optimal for the crickets. And when I say leave, any and all living creatures, when they're in a situation that will cause them to die, will escape that area. So basically my death count is what will tell me if the experiment is successful or not. And they all get the same amount of food. Before I put them in their testing areas, I had put 1/6 of an apple into the area to see how fast they would eat it, and they ate it within a day or so. So I put 1/3 of an apple into each of them, which is the approximate amount that I had placed on my procedures. That would be 1.183 deciliters, which is equal to half of a cup. So there's half a cup of apple in all of these. So for box 1 would be getting 5 milliliters, so I would take out my measuring cup that has milliliters on it. So you probably can't see it very well, but there we go. Here it says 10. This is measuring in milliliters, but that's 10, and then there's a little half sign here. That is 5 milliliters. So I would put this down on the table so it's balanced. And I figured this works best to keep control is a water bottle with a hole in it, so I can have a controlled steady flow and of water. Let's go down here. And you can see the 10 mark. So basically we're going to be filling it up to 5. Yep, it's 5. Ooh, wait, don't. So, yeah, that's 5. And then I would just open up the lid. You can see it like here, not on here, but like you can see that clear thing. So I would open that, pour this in wherever the crickets are not, because I don't want to hurt them. And that would simulate rain. Then over time, it should get warm enough that the water will evaporate from the soil and stick to the sides and then come back down and then be released in a way that the crickets can drink it if they don't drink it from the ground when they tunnel in there. So if you're wondering why there's so much space up here, is because you probably heard the noise earlier, but they like to jump because they're crickets. And in another setup that I had, it was too small in the height, in the respect of the height. So, yeah. And there weren't enough air holes. So, yeah, they died. So I had to restart with a different container. And this one should render better results because this is container specific to crickets. Yeah. So that's it. And so the food is changed. I'm probably gonna, so the food will change about every 4 weeks. And no, the food is changed every week. And one second. Okay, so I change the food every week, and
Did you transmit?
and I'll be doing the water every 4 weeks. So 5 milliliters, 10 milliliters, and 15.